Good morning, third graders. This is your math lesson for Wednesday, June 10th, 2020. You already know what you're going to need to be successful in this math lesson, and just remember that you can rewatch it. And if you have to, go back and rewatch the video from Monday, and let's get started. So, introduction, warm up, review, lesson, and then your assignment. So your assignment is the same as it always is. You know how to submit by now. Just please put the date at the top and make sure you number each of your answers. Makes it easier for us. So our learning goals for today. We've already got 3 of them checked off because this is sort of a 2-part lesson and it builds on Monday's lesson. So I can identify a composite shape. You guys already know how to do that. Composite shape is anything that can be divided into simpler shapes. So right now we're dividing those composites into rectangles. I can divide a composite shape into rectangles. You know how to do that. And remember, you always want to divide it into the simplest shapes you can and also the fewest number of shapes. So if you can divide it into 2 instead of 3, do that. It's going to be really important today to divide your composites as simple as possible. The next thing is I can find the area of a rectangle by multiplying length and width. You guys know how to do that because you've been doing it for about 3 weeks now. So that's just the area formula. We're going to be bringing that into composites today. And the last thing is new, and we'll have it by the end of the day, is I can find the area of a composite shape by adding each rectangle. This part is new. You already know how to do the other ones. So let's get going here. Oh, there's Russell Wilson kicking down a brick wall. So, warm-up problem. What are 2 ways you can decompose this shape, and how can you find the length of the missing side? There you go. You can figure that one out on your own. Go ahead and pause and warm your brain up. So thinking back to Monday's lesson, for decomposing this shape, we could draw 2 lines. You could draw one that goes across here. Oops. And divides it into 2 simple rectangles. So we'd have figure 1 up top and we'd have figure 2 on the bottom. So if you drew a line there, you'd have 2. Or you could draw a vertical line here and you would have 2 as well. You'd have 1 here and then you'd have kind of a long skinny one here. So there's 2 ways to do it. Now to find this missing side, that is the total vertical length. So from top to bottom, you can just add up these 2 pieces here, 5 and 6. You add 5 and 6, this missing side would be 11 centimeters. So that's how you do that. Quick review for you. Now you're ready to go. So when we're trying to find the area of a composite, we have to first decompose the shape and label them. So you can do it 2 ways, but for the sake of today, I want you just to kind of follow along with me. We look at this composite here. We see that every side is labeled, so that's good. It's not always going to be that easy, but today, or for this one it is. We have to decompose it first. So I'm going to draw a line right there, and then it says to label the new shapes. Because now we have 2. We have this one up here, and this one down here, 1 and 2. We decompose the composite. We have 2 shapes. We good? All right, let's look at our next step. Second, you need to write a length and width equation in each new rectangle. We're trying to find the area of this whole thing. So we need to write a length and a width equation for each one. So we have figure 1 and we have figure 2. We need to look for the length and width of figure 1 and figure 2. This can be kind of tricky, especially when we look at number 1. We have 3 measurements here, 4, 5, and 10. But only 2 of those are the length and the width. 4 and 5 are the numbers we're going to multiply here because we need to remember that 10 is the entire length of this whole shape. But we're not looking at the entire shape anymore. We're only looking from this line up. So don't make that mistake when you're solving for area. Multiply 5 and 4, 6 and 11. We have 6 here and 11 down here. Remember, you're looking at the length and width for the new rectangles that you divided, not the entire figure. So make sure you are paying attention to that. So we write the length and width equation for each new rectangle. There's that one, and there's that one. And this is where it all comes into review. So we need to solve for each one. 5 times 4 is 20. So this figure 1 is 20 square inches, and 11 times 6 is 66. So the area for figure 2 is 66 square inches. So for the entire composite figure, we're going to have to combine this number and this number. So it says last, add the areas of each figure to find the area of the composite shape. So we have to combine, and when we combine in math, we use addition. Combining 20 and 66, 20 plus 66 equals 86. So the entire area of this composite figure, this blue L-shaped figure, is 86 square inches. So there was a couple steps. I'm going to walk back through them, and then we're going to work together on the next one. First, we divided and labeled. Then we found the area for each figure, and then we added the area, and we got the total area. So one more time, we divide it into 2 figures and label them. Then we find the area for each figure. Then we add those areas up, and we get the total area, which is, in this case, 86 square inches. And that's where those numbers came from. There we go. So let's walk through this. I know it's kind of hard to draw this on a piece of paper and label it. If you feel like you want to do that, you can pause it now and you can draw and label that figure, or you can watch me do it and we can work through this together. So the first thing to do is to draw a line to decompose the composite shape and then label them. There's a couple different ways you could decompose this, but for right now, we're just going to draw a line down that way. So now we've got this figure here and this figure here, figure 1 and 2, and that's step number 1. Divide and label. Now we need to write the length and width equation for each new rectangle. The length and width equation for figure 1 and the length and the width equation for figure 2. Now, the length is 9 meters and the width is 3 meters for this figure here. When we look at this one, the length is 7 meters and the width is 5 meters. So we can write in our equations 7 times 5 and 3 times 9. Now we're going to solve for the area of each of our new rectangles. 7 times 5, you could skip count that one if you wanted to, is 35, and then 9s, there's all sorts of tricks for multiplying by 9s. Some of you guys might have them memorized by now, but it would be 3 times 9. 3 times 9 would be 27. So we now have 2 areas, 27 square meters for figure 1 and 35 square meters for figure 2. But since we're trying to find the area of the entire figure, we're going to add those together. And we're going to get 62 square meters. So the area of this entire figure is 62 square meters. First, we divided and labeled. Then we found the area for each side. Then we added those together. That's our last step, is to add the areas together. And you get your total area for the figure, which is 62 square meters. Here's another one. Like I said before, I know it's hard to label it. If you want to take the time to do that, or draw and label, you can do it. If you want to just watch me, that's fine too. So first we're going to decompose the shape and label them. There's 2 ways to divide this into 2 rectangles. I did it this way. You can do it however you want. Okay, so now we have to label, and then we need to find the length and width equation for each one. Now this one can be kind of tricky because figure 2, I've got 3 labels here, 12, 10, and 2. 2 is the width, that one's easy. But which one of these is correct? 12 or 10? If you said 10, you're correct. Because remember, we're measuring from this line right here. And so the measurement of this side is 10. We don't care about anything down here because that's part of figure 2. And thinking back to Monday's lesson, if we didn't know what this side was, we would add 10 plus 2, which is this side right here, to get that total length, which would have been 12. But in this case, we're going to use 10 because that's the length of figure 1. So we've got 2 times 10, and we have 2 times 6. And our last step is to solve. We've got 2 times 10 equals 20 for figure 1, and 2 times 6 equals 12 for figure 2. And then we just add those together to combine them, and we have the entire area of that composite shape. 20 plus 12 equals 32 square feet. So the entire area of this is 32 square feet. So just a quick review of our steps. First, you decompose the composite into rectangles. In this case, we drew that pink line. Then you label the 2 rectangles, 1 and 2, just to help you keep track. Then you find the area for each one of those rectangles and pay attention to your labels. Make sure you're using the right ones. And then the last thing you do is you add those 2 areas together, and you get your total area for the composite figure. 12 plus 20 equals 32 square feet. And that's how it's done. So identify the composite shape, divide it into as few rectangles as possible, find the area for each one of those rectangles, and then add the areas together to find the area of a composite shape. And that is how it's done. I've got 3 of them right here. I couldn't fit them all in. I wanted to make sure you guys had enough room. We've got 1, 2, and 3. I know it's really tricky because we don't have a handout to give you to help you solve these. But if you can draw them and label them, just take your time. You got lots of time. Today's lesson was a little bit shorter. Follow the steps and find the area for each one of these composite figures. And your IXL practice is FF15. If this is tricky, go back and watch it again. And if you need a little bit more time or you need help, don't hesitate to message your teacher and say, hey, I don't get this. I need a little bit more help. So that's it for today. You've got your quiz on Friday. Have a great week, and thanks for tuning in.